This is lesson 4 of 7.5, which is solving quadratic equations by factoring. The premise of this section is that if we have a factor a times a factor b is equal to 0, then either a is equal to 0 or b is equal to 0. What we're going to look at in this lesson is how to use that premise to solve word problems. So if we go to part C, there's a word problem here about Jason. So I'll read it to you. It says Jason sells posters. The profit function for his business is P is equal to negative 0.5 n squared plus 10n minus 32, where n represents the number of posters sold per month in hundreds, and P is the profit in thousands of dollars. And the question here says, how many posters must Jason sell per month to break even? So one thing to understand is that this function p is equal to 0.5 n squared plus 10n minus 32 could also, if you'd like to use a y and an x variable, could also be represented this way. And I can show you exactly what that looks like. So this could be y is equal to negative 0.5 x squared plus 10x minus 32. If I was to graph that function, here's what it looks like. So you can see here I've entered the function into my calculator and graphed it. Now the question is asking how many posters must Jason sell per month to break even? So if the y-axis represents the actual profit, so this is the profit, and the x-axis represents the number of posters, what we're actually looking for is when the profit is 0. So in other words, we're looking for these x-intercepts. You could use a graphing calculator, but our focus here is how to do this algebraically. So what this means is that the profit is equal to 0. So how many posters must he sell to break even? What that actually means, to break even, means that the profit is equal to 0. So if I substitute that in for profit, so profit's going to be 0, we could then solve using one of the methods that we've looked at to solve this. So at this particular point, we have 0, which is the profit, is equal to negative 0.5 n squared plus 10n minus 32. And the first thing we want to do, since this first term is not an integer, what you're probably going to want to do is, first of all, factor out the greatest common factor. This is actually something similar to method 4 from the previous lesson. So the first thing I would do is treat this question like it has a greatest common factor of negative 0.5. So if I factor negative 0.5 out of all of those terms, so divide the first term by negative 0.5, that will give me n squared. If I divide 10 by negative 0.5, you can see on my calculator here, 10 divided by negative 0.5 is negative 20, so that will be negative 20n. And if I divide negative 32 by negative 0.5, you will get positive 64. So in this case now, we can factor this trinomial, probably using the box or area method. We've got n squared, we've got minus 20n, and we've got plus 64. So your remaining factors will be, in purple here, n, and in red n. And the two numbers that multiply to negative 20 and add to 64 will be negative 4 and negative 16, because these will be negative 16n and negative 4n. Okay, and those diagonals make negative 20n, and negative 16 times negative 4 is positive 64. So our factors here are all the parts highlighted in yellow. So our equation at the moment is a profit of 0 is equal to a factor of negative 0.5, a factor of n minus 4, and a factor of n minus 16. So the solutions here would be when n minus 4 equals 0, you can look at previous lessons for this, or when n minus 16 equals 0, which gives you, if we solve for n, the first one we'll have n is equal to 4, and also solving for n in the second, for the second factor would be n is equal to 16. So those are the two values of n that give you a profit of 0. Now the last thing we have to look at is the context here. N represents the number of posters sold per month in hundreds. So it would be, in order for him to break even, he would have to sell either 400 or 1,600 posters. And as you can see on the graphing calculator here, this would be 400 represented by 4. This would be 1,600. That's where he would break even. Let's look at the next question. It says if Jason wants to earn a profit of $16,000, how many posters must he sell? Now in this question, since your profit is equivalent to negative 0.5 n squared plus 10n minus 32, in this case it's a profit of, so if the profit equals $16,000, what that means is that P, if you look here, it says that the profit, or P, is the profit in thousands of dollars. So in this case, what we would substitute is not the profit being 16,000, but the profit being 16, because P is represented in thousands of dollars. So if we substitute that in, we would have 16 is equal to negative 0.5 n squared plus 10n minus 32. And in order to solve this, we need to make one side equal 0. You can't solve by factoring or solve quadratic equations unless one side equals 0. So I would subtract 16, and I would have 0 is equivalent to negative 0.5 n squared plus 10n minus 48. And I would again treat this as a greatest common factor of negative 0.5. So if I factor that, I would have negative 0.5. And my factors would be n squared minus 20n and plus 96. And in this case, if I factor this trinomial, what you will get are the two factors that multiply to 96 and add to negative 20 will be, the two values that do that, will be negative 8 and negative 12. So that would give you diagonal terms of negative 20n, and they multiply to 96. So your factors in this case would be 0 is equivalent to, I'll highlight them in yellow, your factors are negative a half, n minus 8, and n minus 12. Which would give you solutions. I'm going to make this a little bit quicker for you, so skip a few steps, but this would give you solutions of either 800 posters, so that would represent a solution of 8, and n is in hundreds, or 1,200 posters.